Good morning Year 5 and welcome to Thursday's maths lesson. Here we are then, let's get started with today's date and title. Get those into your book please. Today's title is Division Remainders. Pause and get your book ready. Okay, if we're looking at today's Wilfs, it's worth pointing out that the bronze for today, for division, features no exchanging. Okay, so we're keeping it really simple in the bronze. Silver does contain exchanging as well as today's skill with remainders. So it's just worth bearing in mind when we choose our task later that there is a decent jump between bronze and silver today, and you're picking the task that's right for you. Okay, let's get cracking with some total recall then. So today's total recall questions are a good challenge. So I would like you to pause the video here and attempt them in your book. Okay, make sure they are well laid out, you're using the right strategies. Remember, you can always look back in your book and see what were we doing last week, how do I solve that, what is the right method for that, and we'll be back with the answers. Okay, so our first question we're going to look at was from Autumn. We're looking at inverse operations. So it says here that 2,362 add 2,351 equals 8,621 subtract something, and we got some kind of mystery value here. Now we know that the equal sign tells us that what's on this side of the equal sign must be the same as what's on this side of the equal sign. When we get to the end, we're going to have two equal values either side. So let's have a look at what we've got. On one side I've got a calculation that I can complete, and then on the other side I've got a calculation that I can't. So the first step for me to do is going to be to add these two parts together so that I get just one number on this side of the equal sign. I've done that here, I've used column addition, and I now know that on this side of the equal sign I've got the value 4,713. Now, I now know then that 8,621 subtract a mystery amount equals 4713. So how am I going to find that mystery amount? Well, I'm going to think of 8,621 as the whole. If 8,621 is the big amount, the whole amount, I can then think of it as being made up of two parts. When I take away the mystery value, I am left with 4,713. I'm left with these two added together. So I can consider green then as the whole. Let's move that red line, I don't need that just yet. And it's made up of pink plus yellow. When I take pink away, I know I'm going to be left with yellow. When I do 8621 minus the pink, I'm going to be left with 4713. That tells me then that when I take yellow away, I'm going to be left with pink. So my next step is going to be to take the 8,621 and subtract 4713. That will then leave me with the value for pink, which in this case is 3908. I wonder if you know a way that I could check my answer using inverse operations. Well, if I go back to my colours, if I said that yellow plus pink equals green, and I now think I know all the values, I can check that yellow and pink are correct by adding them together, safe in the knowledge that yellow plus purple will equal green. That's to say 4713, if I add 3908, just going to do it quickly down here, I should get 8621. Let's try it out. 3 plus 8, that's 11. 1 plus 0, add that 1 is going to be 2. 7 add 9, that's going to be 16. 6 there, 1 across. 4 add 3 is 7, add that 1 is 8. It works. I'm confident I've got that right answer. Okay, and here's last week's. We were looking at multiplication. I was multiplying a two-digit number by a single-digit number. 85 multiplied by 4. The first thing I did was I multiplied 4 by 5 to get 20. I laid the 2 down here and the 0 in the ones column. And then I did the 4 multiplied by 8, which is 32. adding on that 2 to get 34, so the answer is 340. The last one came from yesterday. This is back to division. I'm going to do a little model of this one under the visualizer in a moment. We've got 2 division statements, 3639 divided by 3 on one side, and 2486 divided by 2 on the other. And then in the middle there, I've got this greater than, lesser than symbol. So that's telling me that 2486 divided by 2 is greater than, or a larger number than, 3639 divided by 3. So what we need to do is we need to get those again into single values. We need to find the answer to both these 2 divisions to understand if the statement is correct. Okay, so let's do it. We'll start with this one. I've laid it out in the bus stop method. I've got 3639 underneath the line here. That's my dividend, and I'm going to divide that up with a divisor, which in this case is 3. So 3's into 3, 1. How many 3's in 6? 3, 6, that's 2. How many 3's in 3? 1. How many 3's in 9? 3, 6, 9, that's 3. So it's going to be 1, 2, 1, 3. Now on to the other one. So I'm looking at 2's into 2,486, and I'm going to divide each column up individually. So how many 2's in 2? 1. How many 2's in 4? 2. How many 2's in 8? 2, 4, 6, 8, that's 4. How many 2's in 6? 2, 4, 6, that's 3. Right, so now I've got my 2 answers, 1, 2, 1, 3 and 1, 2, 4, 3, and I'm looking for a greater than. I'm looking for the number that is larger here, or indeed the number that is smaller. Let's start in the ones column. Well, they've got the same value in the ones column, they both end in a 3. What about the tens column? Okay, I've got a 4 here and a 1 here. That's telling me then that this number here, 1, 2, 4, 3, that is the greater number. So my symbol goes this way because we always remember the crocodile eats the bigger number. So let's go back. Was it true? Was it false? In this case, it is true. Right, let's move on to today's learning. We are going to focus on remainders today. So we've looked at division. I know Miss Tallett took you through some division yesterday, but we're going to look at remainders. So we're taking division kind of to the top level. Now this is we're thinking about our division learning as a mountain. We're now reaching the peak. This is as tough as it gets. For that then, I want us to really focus on resilience, that really important learning power that we talk about quite a lot, resilience. Let's stop for a moment though and reflect upon what it actually means. Maybe pause and just have a think to yourself, what does resilience actually mean? What does it look like? Well, I think resilience looks like the ability to recover quickly from difficulties, show mental toughness, show that you are strong, that you won't be beaten by a couple of mistakes here and there, that you will be resilient, you will keep going. It might be that you found multiplication and division tough. Yeah, it might be that the maths we've been doing at home has kind of got you down recently because you haven't had a teacher or a teaching assistant there with you to kind of really give you the help and advice you'd like. You thought you got it, but then you looked at the answers and you realised, oh, these are not what I was hoping for. And being resilient is about really coming back every day, switching the laptop on, getting the YouTube lesson lined up, getting your book out, and without having a teacher there to tell you, we're going to do maths, getting it done yourself and really giving it your best. So I hope you're showing resilience right up to the end of this half term. Let's think about remainders then. If the 4 Year 5 teachers are having a meeting and there are 10 donuts, because if the Year 5 teachers have to have a meeting, it is impossible to do it without any snacks. How many can they each have? Well, what we've got here is a simple bit of division. We've got a large total amount, we've got 10 donuts, and we've got 4 people, well, very hungry people, to share it out amongst. And division is sharing. It's sharing a value into equal groups. That's really important, equal, so that everyone must get the same. So if we're sharing out these donuts, we can give one to Mrs. Lee, and we can give one to Mr. James, and we can give one to Miss Tullett, and I'll have one as well. We can give another one to Mrs. Lee, we can give another one to Mr. James, we can give another one to Miss Tullett, and I'll have... Oh, what's happened there? Oh, I had a little freeze there, sorry. I'll have one as well. Now we run into a problem though, because I can give another one to Mrs. Lee and I can give another one to Mr. James, but that leaves Miss Tullett with 2 and Mr. James with 3. That leaves me with 2 and Mrs. Lee with 3. And that doesn't seem very fair. Well, realistically, they can each have 2, and we just have to have 2 left over that we can't share equally. And this is the kind of division we've been doing where we've had our remainder as an R value. So we have 2 donuts, 2 left over. So 10 divided by 4 is 2 with a remainder of 2. Today we're going to think about how we can express these remainders then. So we can leave it just as a remainder like I just did, and that's going to be the bronze for today, to show your remainder as an R value, R2. Or we can split it, and silver are going to think about this as fractions today. So once we get to the point where everyone's got 2 donuts, then Mr. James goes to the kitchen and comes back with a knife, and we can then halve these donuts, look, so that everyone gets an equal amount. We can split the ones down into fractions and share those fractions out. Gold is going to be to do it similarly, in a similar way, but instead of thinking about it as fractions, as remembering that decimals are 1 split into smaller amounts. So in that case, we've got, instead of half a donut, we're saying 0.5 of a donut, or 5/10 of a donut. So bronze for today, we're going to find the remainder and we're going to show it as an R remainder. I'll show you what that looks like now under the visualizer. Okay, so I've got 4,806 underneath my line with 4 over to the left hand side of it. So that tells me I'm going to be taking 4,806 and dividing it into 4 equal parts. I'm going to do that each column individually, finding how many 4s I can make in each number. So I'm going to use my 4 times table. I have in my mind today, I'm going to use my 4 times table for this one. 4s into 4, so that's going to be, with 4 I can make 1 4. How many 4s can I make with 8? Counting in 4s, 4, 8. Okay, I can make 2. Now then, how many 4s can I make with 0? 0. None. If I've got no sweets, how many groups of 4 can I make? None. If I've got no cabbages, how many groups of cabbages can I make? None. 0 means I can't make any, so I must put in there that I can make no groups. Okay? 6. How many 4s can I make of 6? How many 4s are there in 6? So counting up, I go 4, 8. Right, so I can't use 8 because that's too big. So I'm going to say I can make 1 group of 4. And because I used 6 here, I need to think about the difference between 6 and 4. The difference between 6 and 4 is 2. So that tells me that there'll be 2 left over. If I go back to thinking about those donuts, and those donuts all shared out. I had 4 people, 6 donuts. I gave them each a donut. I've got 2 donuts left over. That is my remainder. That is what is left at the end. So today for bronze, you're going to show that as R2. 1201, remainder 2. Okay, so bronze then, let's see you have a go, please. In your book, I'd like everyone to have a go at this one. Pause the video here and answer 3,605 divided by 3. Okay, so I hope you've got your answer and you've shown your remainder with an R. You should have 1201 R2, so 1201 remainder 2. So that means if I take the number 3,605 and I split it into 3 equal groups, each group gets 1,201 and there are 2 left over. So that's bronze for today. What I'm going to do now is I'm going to show all of the tasks at this stage and just explain to you how the tasks work. Then bronze can get started on the task, or if you want to do silver or gold, keep listening as I'll talk you through them afterwards. So let's look at the task now. Today's task is a code breaking task. For each bronze, silver and gold, you've got a different code to use. So here's bronze, here's silver, and here's gold. Let's look at the bronze then. Each letter has a number associated with it, and you'll notice that almost all of them have remainders. Some of them don't. You're going to solve each division. So I'm going to do number 1, 3665 divided by 3, and I get my answer, and then I'm going to try and find my answer here, and that will get me the letter. So if, for example, for question 1, your answer was 2111 remainder 2, 2111 remainder 2, looking at, here it is, 2000, oh sorry, I've highlighted too much there, 2111 remainder 2, that would tell you that the first letter is O. It's not, I'm just using it as an example, alright? So, do that 6 times and it should spell out an answer. An answer to what? Wow, the biscuits in the staff room have all been eaten before break time. The teachers are furious and the culprit must be found. So, bronze, discover who stole all the biscuits. You should get your answer. If you have success, bronze, and you'd like to carry on, you could come back to the video, have a listen to the silver, and have a go at the silver and see if you can solve that. Right, silver and gold work the same way, but we're going to use a different skill today. So you can't do the silver yet. There's no point trying to do the silver, no point trying to do the gold because we haven't looked at it yet. Silver, we're going to use our remainder expressed as a fraction. To do this, we put the remainder that we found on the top and the divisor on the bottom. Our remainder becomes the numerator, our denominator is the divisor. Let's go through this slow time. So 6 is into 7, 1, remainder 1, yeah, 6 into 12, 2, 6 is into 8, 1, remainder 2, 6 is into 25, that's going to be 4, because 6 times 4 is 24, I've got a remainder of 1. So I would then write out R1, just like I did for bronze, but for silver I want to express that as a fraction. I take the remainder and I put it at the top of the fraction. That's how many parts of the whole I've got. I've got 1 part. The whole has been split into 6, so that goes as the divisor, as the denominator on the bottom. I get that 6 because that is what I've divided by. Because I've divided by 6, the 6 goes to the bottom. Because the remainder was 1, the 1 goes to the top. That's how we construct the fraction. Let's check and see if we understand that then. I'll do the first one together and then you can try the bottom 2 in a minute. 2,489 divided by 4. I've got the answer there. It's 622 remainder 1. I want the remainder as a fraction. So I'm going to use the 1 and that is going to go on the top as my numerator because that's the remainder. I'm going to use what I divided by on the bottom as the denominator. Numerator is the remainder. What I divided by becomes the denominator. So in this case, I'm going to use a 1 on the top and a 4 on the bottom. That tells us then that this answer would be 622 and a quarter. I don't need to use an R anymore. My answer would be 622 1/4. Can you apply those skills then to give me the answer to the second and third one? Pause and have a go. Right, let's have a look then. We had 1 as the remainder, 3 was the divisor. So this answer would be 799 and a third. In this example, 645, remainder 2, so I've got 2 on the top. I divided by 9, so 9 on the bottom, 645 and 2/9. This is because what's remaining is the amount of parts left. And remember 9 in this last example, what you divided by, that is how many parts make up the whole. So 9 parts make up the whole, and we've got 2 of those parts left. So it's 2/9. Right, I'll show you one in the book now. I'm doing 5, 7, 5, 1, and I'm going to divide it by 6. So I'm going to do 5, 7, 5, 1, and I'm going to divide by 6. If you don't have a ruler, you can always improvise something like I have here. There's my bust up. So now we've got exchanges. So as we go through it, I'm going to remind you how to do that. 6s into 5. Well, I can't make 6 out of 5. It's not big enough. So that tells me that I need to bring it across into the next column. That creates 57. How many 6s are in 57? Well, I can sit here and I can realise, okay, I'm using my 6 times table. I could count out my 6 times table. If you want to, you could use a multiplication square, that would be okay. Or you could even write out your 6 times table if you feel that you need to. Or, I think we can think of some better ways. I can go to one I know, straight away. 57, that's close to 60. And I know that 6 times 10 is 60. That's too big, so I'm going to need to go down one. So then that tells me that I'm going to use 6 times 9. Okay, what's 6 times 9? So I'm using 9, so I'm using my 9. So 6 finger down, 54. Good. Right. So I'm going to use 54. I'm going to say that it's 9 6s in 57. But because I've used 54, I need to know that difference between. The difference between 57 and 54 is 3. 54, 55, 56, 57. 3. That 3 then I'm going to bring across into the next column. 6s then into 35. I want to know how many 6s I can make with 35. Okay, let's go back to the 6 times table then. So 6 times 5 I know is 30. I know my 5s and 10s really strongly, so I know that 6 times 5 is 30, so I could use that. Is that the right one? Let me go. It's not quite enough, is it? It's not quite up to 35, so let me go to the next one. That'll be 6 times 6, so I'll add on 6 is 36. 35 here, 36 here. So this is too big, I can't use that one. I'm going to have to use 6 times 5, so I can make 5. What's the difference then between 30 and 35? 30, if I take away 30, it's going to be 5. So I bring a 1 in here. Now I want to think about 6s into 51. Okay, look at what I've got here. Alright, well I used 6 times 9 was 54. That's too big. Let me go back one. 6 times 8 maybe would be, take away the 6, 48. That's going to be the one, isn't it? So I'm going to use 8. What's going to be left then between 48 and 51? I need to find that difference between them. 48, 49, 50, 51, it's 3. Okay, I've got nothing else to put it next to. That tells me that it's my remainder. So I've got a remainder of 3. Not quite a busy page here. I'll just rule that off. This is the kind of jottings that you might make things like this. You might not. I always say to children in my class, if you want to add in these jottings, if you want to put your brain onto the page, go for it. Because we can't hold lots of numbers in our head. Get them down on the page and I can go back to them. Anyway, here's our answer. 958 remainder 3. But we want to show it as a fraction. So we've got 958. Remainder goes to the top. Divisor goes to the bottom. So in this case, it would be 958 and 3/6. If you're writing fractions in your book today, you could squeeze them into one box like this. Equally, you could show it like this. The diagonal line, the numbers in 2 boxes, or you can show it like that as well. All right, it's up to you on which looks best in your page and depends on your sort of number writing style. So give it a go, I think. Here comes your question. 8287 divided by 4. Everyone who's still with me, even if you think you're going to go for gold, I'd like you to pause and complete that one in your book, please. Right, here comes your answer then. The answer is 2071 3/4. So I was left with a remainder of 3 and I divided by 4. So that tells me I go 3 on the top, 4 on the bottom, 3/4. So that's silver. If you feel like that's the right kind of level for you, now it's time to get cracking. Grab your silver sheet from files and get going on it. But we're going to talk about gold. Gold can be expressed as a decimal by continuing to divide beyond the decimal point. So after we get to the ones column, we're going to keep dividing. So here we have 7285 divided by 4. I've made my way through it. I've got to the point here where I've divided 4s into 5. Look, I've made 1, and then I've got 1 left, haven't I? I've got 5. I've made a group of 4. I've got 1 left. What I'm going to do then is put the decimal point in the answer and in the dividend in what I'm dividing up. That's going to have a decimal point in it as well. Then I'm going to put in some placeholder zeros. I can do one at a time, or I can put a few in before I start, so that I can bring the remainder in just like I normally do in a bus stop. Then I'm going to look at it as how many 4s are there in 10. Well, there are 2 4s in 10 because 2 times 4 is 8 with a remainder of 2. So I bring the 2 in above the 0. How many 4s are in 20? 4 times 20 is 5, so it's spot on. 5. There are no more remainders, so I don't need any more zeros and I don't need to keep dividing. I've got my answer. It's 1821.25. Right, let me talk you through one of them in my book then. I'm going to do similar, same one I did earlier, but I'm going to do it in decimals. So we've got 4, 8, 0, 6. So I'll double check my question. Yeah, I'm dividing by 4. And I'm going to divide by 4. Alright, I shall just get my page steady there. I'm going to bring in my bus stop. It's worth at this point, because I know that what I'm doing, I'm going to let my line continue further on because I know I'm going to need some extra space here. So 4s into 4, 1, I'm going to go quick here, 4s into 8, 2, 4s into 0, 0, 4s into 6, 1, and then there's a remainder of 2. So decimal point goes in, and that's going to go in the answer and the dividend. Then I'm going to put in a 0 here. The remainder, when I divided 6 by 4, was 2, so I place that 2 up there. Now 4s into 20, that's 5. Nothing else to divide up, no more remainders. If I did have more remainders, I'd include another 0 and bring it in there, but I don't have it, so I don't need to worry about it. I've got my answer. 4806 divided by 4 is 1201.5. There's my answer. Right, time for you to have a go there. I'll tell you that for yours, you're going to need 2 zeros after the decimal point for your answer. Pause the video and have a go. So, should have 2071.75. 2071.75. You might have noticed it was the same one as silver, but when we express 3/4 as a decimal, it's 0.75. Okay, so there it is. On to the task now then. So head over to Files, grab your sheet for today, your code breaking sheet, whether it's silver or gold, or you may even have a chance to have a go at both. And I'll see you back here tomorrow for our next division lesson.